So quickly about me, I won't waste much time. I'm Sripathi. I'm the CTO at HashedIn. Long-time contributor to the Redis. I've spoken at several Redis cons in the past. We also built a product called as RDB Tools, which Redis Labs just announced that they'd acquired. But this talk is, this is a travel adapter, and I come from India for this talk, and one of the challenges traveling internationally is power adapters, right? And why is this slide up over here? This is a cool little thing which lets me connect my laptops, my devices, which are on a totally different plug, to the US power grid, right, essentially, right? And that's really what this talk is all about, right? How can you build your applications? I mean, your applications already perhaps talk to Kafka, right? Is there a way to, without changing the source code of your applications, instead make it talk to Redis Streams, right? And that's the whole idea about this talk. Over the next 30, 45 minutes, the idea of this talk is to compare and contrast both the tools. So what's good in the Kafka ecosystem, what's good in Redis Streams, and how can you marry the two systems, right? That's essentially what the talk is all about, and I'll have a short demo at the end of it. Crash course on Kafka, a little bit on Redis Streams, and then how do you merge the two together, and a quick demo after that. That's essentially what this talk is about. Before we get started, I mean, how many of you are familiar, worked with Kafka? Oh, quite a bit. And Redis Streams? OK. So more with Kafka, right? So I'll accordingly adjust. So quick introduction to Kafka. Kafka is all about this producers. There's, so I'm going to talk more from a logical point of view and not how physically in the network it looks like, right? So if you think of Kafka as a black box, it's essentially topics. You've got producers and consumers, right? So producers write to the topics, and then consumers read from them, right? That's the essence of it. But if you drill down into a topic has several partitions. And so producers are actually not writing to a topic, they're writing to a specific partition in a topic, right? So that's right. The partition is a fundamental way for Kafka to scale out. You can have the same logical topic represented by multiple partitions on different servers. But logically, that's what it is, right? You've got producers writing to partitions. And then consumer side is categorized into two things, right? So when you've got consumer groups are, technically they are each consumer group is different from the other, and you typically use them for one business use case, one application, right? So for example, over here, we've got a billing engine, we've got an anomaly engine. They are totally independent of each other, and they are separate consumer groups, right? And then within a consumer group, you have consumers, several consumers. And what Kafka does is each consumer is looking up at multiple partitions, but the reverse, right? Only one partition is only served by exactly one consumer, right? That's how Kafka guarantees that. Oh. So let me say that again, right? So one partition in Kafka, there will be only one consumer reading from it. This way, Kafka can guarantee that the records are only processed in strict order, right? That's the whole philosophy behind a topic, partition, and a consumer. Now, what happens when a consumer within a consumer group dies, right? It's no longer functioning. So what Kafka would do is it would reassign that partition to another consumer in the same consumer group, right? So in this manner, the fundamental axiom that is one partition is only served by one consumer, that still holds true, because Kafka has now swapped out the old consumer and the new consumer takes over, right? But it's all within the same consumer group. Now, drilling down further into a partition, right? So what does a partition have? A partition has records, right? Each record is numbered in strict increasing order with a long, right? So it's called the offset. And so a partition in Kafka has these records. Each record has a key, a value, some headers, and a timestamp. right? So that's really what a record looks like within Kafka. So if you now think about it, there are topics. Topics have partitions. Partitions have records. And you can think of a partition as an array, right? It's an ever-increasing array of records, and the index of that array is what's called the offset, right? So, and the offset is only unique within a partition. So different partitions can have different number of offsets, essentially, right? I mean, different number of records, and therefore different offsets. One more important thing, so when a consumer reads, right, what happens is Kafka remembers what was the last record that the consumer read. Right? So the consumer has a separate mechanism to indicate Kafka that I have read up to this point, and I'm committing this offset. So when the consumer says, I have read up to offset number 33, for example, right? Kafka will store that, and Kafka will make sure that if the consumer crashes, and later on some other process picks up the same partition, Kafka will ensure that records are read from 33 onwards, so 34, 35, and thereon, right? So that's an important feature, which is Kafka remembers the last commit position of each consumer within a consumer group. And that's an important property. So if you think about it, you look at the what does Kafka store, right? It stores that for this consumer group, in this topic, for this partition, this is the last commit offset. And that's essentially a data structure that Kafka would have internally, right? Within this topic, within this partition, this consumer group is at this offset. That's basically the fundamental in data structure that Kafka would have to maintain for this feature to work. And that's important because we'll come back to this when we're talking about Redis. OK, so that's broadly what Kafka does at a logical level, right? At a physical level, there's, of course, a lot more going on. But at a logical level, that's what you need to understand, right? Now, let's look at Redis Streams instead, right? Now, Redis Stream was inspired by Kafka, but it's a different implementation. There's several, so we'll talk about the logical layer, but at the operation level, right? Kafka persists things to the hard disk. Redis, all the records are in memory, even though you have persistence enabled, but at any given point of time, all the records must be in memory, right? So there are different use cases for Kafka versus Redis, but we'll skip that and we'll talk more about it at a logical level. What does streams look like? And since most of you are not so familiar with streams, I'll spend a little more time on the streams portion and how it looks like. So broadly, it looks similar, right? You do have producers, you do have consumers. And it's the same Redis client library that you have. It's just a different set of commands to act as a producer, different set of commands to act as a consumer. But broadly, it's the same thing. You do have, instead of topics, you have streams. So a stream is essentially just a key. The value is a stream. The value would be an infinite list of records. That's the only difference, right? So you don't call them topics in Redis. You just call them as streams. So there is a new command. Well, there's a command called as xadd, right? Xadd is to add a new record into the stream, right? On the other side, there are two different commands. One is xread and xrange. So xrange, think about it. I mean, let's go back to our earlier conversation, right? What does a stream look like? You can think of it as an infinite array, right? So xrange is basically returning a subset of that array, sublist of that array, right? So you basically say, I want elements from this position to that position. That's what xread gives you. Xrange, on the other side, can do a blocking operation. So think of it like, what happens if there are no records in the stream? So xrange lets you say, give me records after this position, but also please wait if there are no records, and you can wait for like 10 seconds. Or that's a configurable. That's a parameter that you pass to the xrange command, right? So these are the two operations that a consumer would do, right? So xadd to add records to the stream, and xrange to get the records out from the stream. But here's where the difference start coming up, right? The first fundamental difference between Kafka is what is the record? What does a record look like? So in Kafka, notice that a record was a timestamp, a key value, and a set of headers, right? But in Redis, it's essentially a dictionary. every record in Redis has a primary key. You call it like a primary key. You can call it as an entry ID. That primary key is made up of two components, a timestamp and a counter. So if you look at the header over here, right, the top is what the primary key looks like. It's a timestamp in milliseconds, followed by a running sequence number, right? And the structure is key value pairs thereafter. So it's like a dictionary, and every entry in the stream is a dictionary. You can have any key value pairs you want. So this is imagine that you were monitoring servers. Your key value pairs could look like this, right? So you could say the server CPU is this much, and a bunch of things, right? So important thing, important big difference is in Kafka, an offset is just one long, right? And it is an ever incrementing long. Versus in Redis Streams, the primary key is essentially two numbers, a timestamp in milliseconds, followed by a running counter, right? So that's an important difference over here. So the timestamp actually looks like this. Over here, I've just condensed it so that it's more readable, but it will essentially look like a Unix timestamp followed by a running sequence. So the running sequence number is if you add two records at the same millisecond instant, then the running counter just keeps incrementing it, right? So that's how a record looks like in a Redis stream. So the next thing is consumer groups, right? Now, remember that in Kafka, the consumer groups was a way for you to partition your data such that each consumer is only reading one or more partitions in the same strict order. So Redis also has consumer groups, but they work differently. So the way consumer groups work is different from what Kafka does, and I'll talk a little bit about that. So the way, the command for you to build a consumer group is the xread group. So it's like xread, in which you basically say that give me more records from the stream, but you can also specify a group ID. And so the way consumer groups work in Redis is that Redis, the database itself, will partition the records, and it will say, I will give record ID 1 to this consumer, record ID to the other consumer, record ID 3 to the third consumer, right? But there is no concept of partitions. So it's basically dividing all the messages to all the consumers in the group. What that means is, unlike Kafka, where messages would be processed in strict order, if you are working in a consumer group in Redis, you can get messages out of order. Message 1 goes to consumer 1, 2 goes here, 3 goes here. If that message is still pending, the fourth one can go to the other consumer. So 1, 2, and 3 records are not being processed in strict order, right? There is no concept of a partition in Redis, right? And so that's a fundamental difference. If we have to build a concept of partitions in Redis, we will have to emulate that, right? So that's an important difference over here. So another thing is, how does commits happen, right? So notice that in Kafka, so what do you do, right? When the consumer says, I have done so much work, the consumer says, I have processed records up to this offset, which means that what it is implicitly saying, all records with a lower offset, I've already processed it. So in Kafka, a consumer is only giving one number and says, I have processed records up to this point, right? In Redis, it's not like that. In Redis, what you have to do is the consumer has to acknowledge each record that it has processed, right? So it's not, so if you acknowledge record number 33, it does not mean that 32 and 31 have been processed successfully, right? You have to individually acknowledge each message or each record that you're working with. And that's a difference, right? That's another fundamental difference, that if we have to build an adapter which works for Redis, we'll have to acknowledge for this difference, which is when a client says, I'm done up till this point, you have to make sure that all the other records are also done, right? So that's another big important difference that we'll have to reconcile when you're building an adapter. A third more important difference is in Kafka, when a consumer crashes, Kafka will reassign that same partition to another consumer in the same consumer group, In Redis, there is no such thing. So in Redis, instead what happens is, when a consumer crashes, it's the job of other consumers to ask Redis, what were the messages that are already pending, and can I claim those messages? So another consumer can go to Redis and say, I want to claim the messages that the other consumer was processing, right? So there is a separate command called as exclaim. And what exclaim does is, it tells Redis that this record, which was processed by that failed consumer, forget that. I will now start processing it, right? So the way the way failover works is consumers have to be more intelligent, and they have to go to Redis and specifically ask, give me the records that someone else was doing, and let me start processing that, right? It's a great feature. It's just that it is different from the way Kafka works. And so there has to be some way to reconcile that. But it's great if you, so exclaim and consumer groups in Redis, a great feature when you want to do distributed task processing, where the order of task is not strictly important, right? Let's say that you're sending emails or doing some background job or background processing. In that case, it's a great feature because if a task can't be done by one consumer, another consumer can take over and start doing it. The strict order doesn't matter, right? So in that case, consumer groups implemented by Redis, great functionality. But if you're trying to emulate what Kafka does, then you have to have a strict order guarantee. And that's where Redis does not hold up to that promise that Kafka does. So how do we reconcile, right? How do we reconcile these differences? So let's at least summarize what's the differences between the two worlds, right? So first up, there are no partitions in Redis, right? Second, the unique ID that you would have for a record is different. Remember that in Kafka, the unique ID was one long, versus in Redis, the unique ID is two longs, which is a timestamp followed by a unique incrementing number. So that's the second difference. The format of record is different, which means that in Kafka, you've got named fields, like you've got a header, you've got an array of headers, you've got a key, a value, a timestamp. Versus in Redis, it's a dictionary. So arguably, I would say that Redis has a more versatile data structure. It's just a dictionary, right? In Redis, you can split records between consumers in a group, but then you can't then process them in sequential order, right? So if you want sequential processing, then you don't get partitioning. But if you decide to have partitioning, then you don't get the order sequentially. So it's take this or take that, but you can't do both. That's the way it works in Redis, right? The next is, of course, you have to act or acknowledge individual records in Redis, versus in Kafka, you say, I am done up to this point. So that's another fundamental difference. And finally, I mean, this is arguably the one feature that you cannot reconcile without server support. There is no failover mechanism similar to what Kafka has, right? So there is a failover mechanism that works, but in a different manner. And if you're trying to build an adapter, then that doesn't work, right? So so now if you're building an adapter, these are the fundamental differences that we must sort of bridge and go from there. So the question, right? I mean, can you still use it given that these differences? Yes, there is a way to do it. I'll sort of walk you through that and do a demo. But the larger question, why do you even want to do it, right? The Kafka ecosystem is fairly rich and mature, right? The APIs have been around for a while. There is a whole bunch of ecosystem built on top of it, right? So you've got Kafka Streams, which is a great stream processing library. You've got a connector ecosystem, so you can bring in data to Kafka and push it out from Kafka to other systems. There's a whole bunch of layers and layers built on top of Kafka, right? And what this talk is exploring is essentially, can you build that adapter? And then therefore, from there on, can you leverage all the libraries that have been built on Kafka, but instead just make them work with Redis, right? That's sort of why the motivation for this talk, right? Why the motivation for this this open source project, right? the other aspect of it is Kafka, not every use case requires a complex system like Kafka, right? There are places where you can survive, you can work with the guarantees that Redis offers. And in such use cases, just replacing Kafka with Redis and getting your code working without having to make code changes is a great thing. And when you do mature and when you do scale out and you think now you need Kafka, it's just a matter of changing your configuration moving on. So that's sort of the inspiration for this. So the answer to this question is yes, you can get it work, but it's not yet mature, and I'll walk you through that. And B, it will take some time and effort from a lot of folks right now to just sort of make it more mature. But that's where we are, but we'll walk through that. So in an adapter for Kafka producer, what does it look like, right? So this is the Kafka API on the producer side. You essentially have a send method, and the send method, you give it a producer record with the key value, and then the broker sort of returns that. How do you make this work in Redis? So Kafka has an interface called as a producer, right? There's an implementation which is Kafka producer. So what we have done is essentially make another implementation of that class, which internally uses the same partitioners, the same serializers, deserializers, but instead just pushes that record to Redis. And how does it do that? It just calls the exad thing. One important thing that we do, though, is we don't treat a topic equal to a stream. We say that a topic and one of its partition is what a stream becomes a stream, right? So if you want to start writing records to Redis and imitate that your Kafka, one topic will correspond to multiple keys, such that each partition in what would have been Kafka is now one Redis key with a stream, right? So when you're trying to write to Redis in this adapter, what we do is we find out what partition do you want to write to, and then invoke the exad command on that specific partition, and we serialize it. So we serialize it because it's a dictionary. You can store whatever you want. So we use the same serializers, to convert that record into something that can be stored in a hash data structure inside a Redis stream, right? So the trick over here is essentially say a partition corresponds to one Redis stream, right? And I can walk you through what this code does in a moment. But so yeah, you essentially have one partition mapped to a stream. So the format of records is different. So what you end up doing is you essentially take each of the named values in Kafka, you serialize it and put it a special key, right? So you say underscore key maps to the key that would have been in Kafka, and underscore value maps to the value that would have been Kafka. So essentially, because you have a dictionary on the Redis side, you just put in a constant in the key for the dictionary, and the value is the serialized raw object, right? So that's how you sort of marry the two systems from a producer side. Now, this is the challenge, which is producers of Kafka expect to return an offset of the record that was actually inserted into Redis, inside Kafka. So how do you, if you're writing records to Redis, how do you generate the same offset, right? So notice that these are two different things. So there is no lossless way of saying take two longs and convert that into a single long, right? You can't do that, but you can make some assumptions, right? So if you make some assumptions by saying that Kafka offsets don't necessarily have to be sequential, which means that as long as they're increasing, it's fine, right? So you make that assumption, and then you start off by saying timestamps don't have to be forever, for eternity, right? So if you have a reduced timestamp of, say, like 100 years, you're good, right? So if you make these assumptions and some assumptions like this, what you could do is, with a reduced precision of the timestamp and a reduced precision of the sequence number, you can combine both of them and generate one long such that it is reversible in both directions. But the producers will not get sequential. You will get incrementing IDs for the offset, but you will not get sequential. So you may have 30, and then suddenly the next record would be 45. It's still increasing, but it's just not sequential. So if you do these assumptions, you can sort of translate a record ID from Redis to an offset in Kafka and vice versa. So that's a hack, and it works, right? Alternatively, Redis also has an option to generate IDs that are generated in the library. It's possible. It's just that you'll have to build a separate counter, and you have to write a Lua script for all of that to make it transactional. So far, the promise of just converting two longs into single one works, so we've not explored this option. Next, on the adapter for the consumer side. So on the consumer side, what would it look like? You have a poll. So this is the Kafka API, right? You have a poll method, and the poll method, you give it a duration, right? The implementation of this would essentially convert it into an xread command. So the xread command takes a count, which is how many records do you want to read, how long do you want to block, which is the timeout that was given, and you can read from multiple streams at the same time, right? That's something similar that Kafka also allows. In Kafka, you can subscribe to multiple topics at the same time. So in streams, you basically convert that into this command where you specify each of the stream IDs, each of the stream keys, and the IDs will then become whatever was the offset that you had stored. You convert that into the record ID in the bidirectional way, and you sort of make this command. So the adapter is just doing some munging of data to get this command, and then it fires off this command, and then whatever is returned, it's converted back into a format that Kafka drivers expect. The last thing is how do you manage the offsets, right? So you essentially cannot use the consumer groups that Redis ships with, because there's a fundamental difference between how it does its management versus how. So essentially in the driver, what we are now doing is having a separate map which tracks the position of each consumer. And it's essentially the same thing that you saw earlier in Kafka, right? This consumer within this topic and partition is at this offset. So you sort of manually manage that in a separate hash in Redis. OK, I'll do a quick demo on how it sort of looks like. So I'll just quickly walk you through this code. But this is can you guys see it OK? OK. So this is a regular Kafka code, right? There is no difference. I'll specify where the differences are. But broadly, this is a standard Kafka producer and a standard Kafka consumer. And the only changes are when you're making the producer object. So this is how you make the producer object, this portion. The only difference is this one, where you're saying instead of bootstrapping Kafka brokers, you're now bootstrapping the Redis. So we're saying localhost 6379, which is the Redis port. And instead of saying make a new Kafka producer, we're just saying make a new redcaf producer. So it's exactly the same syntax. It's just the producer implementation name changes. Apart from that, it's all the same. So I'm going to run a producer first and push some records into a stream. And just to sort of show that it works, I'll just have I'm just running the monitor command so that you sort of see the commands that are going into Redis. And then let's hope it works. So this has written some number of records into Redis. And if you look at what's happening over here, you see that it's essentially calling xadd with the data that we pushed it, right? So every time the producer is saying send, it translates it into an xadd command and sort of does that and pushes into Redis. So you've got your data getting into Redis now. Let's do the reverse. Now, let's run the consumer on this, right? So when you run the consumer, it's the same code. What it is doing is it's going, looking at that partition, at the topic, and saying, get me the records from that topic, right? And so when I sort of run this, it sort of fetched all of those records from there. And if you look at what it does internally, on the monitor command, it's actually issuing a X read command and trying to fetch records, right? And the consumer is sort of blocking, so it will keep polling till it gets records, right? Yeah, so that's a quick demo. The source code for this implementation is on GitHub. It is still raw, but there is a library under HashedIn redcaf, which sort of has the producer, consumer, and the admin client, and a bunch of different internal things that's needed to pretend to be a Kafka library, right? So all of that code is there. Now, quick summary, right? Interoperability is a good thing, right? Trying to have a library that sort of talks to different systems makes it more accessible to a lot of people. It's huge. An adapter would help in this transition, but it needs work. I mean, think of it as a proof of concept. Please don't use this in production. I mean, it is a proof of concept. It is meant as a way to find out what's the difference between these two systems, what's good, what's bad. But it is a proof of concept. It requires more work. Happy to have contributions. There are several internal, like I did highlight the more important decisions that we were taking, but there are several internal things that that the implementation has that could do with some critique or could do with some feedback. Happy to have a conversation on that. And yeah, that's the disclaimer, and that's the repository. Great. Thanks so much, guys.
Any questions?
Great talk, thank you. Which way do you think people will go more likely?
Can't hear you.
Sure.
Oh,
So great talk. Which way do you think people are likely to go? Do you think people are more likely to start with Redis, Streams, kind of get the most bang for the buck and then upgrade to Kafka? Or do you think people are more likely to start with Kafka and then say it's great but not worth the headache and let's just downgrade to Redis Streams? But again, the adapter is an awesome idea.
Yeah, I don't know which way the community would go into. I really don't know, but Streams is a great API. It's different from, it's right now difficult to do streaming kind of applications with it, but there are several other use cases, and Salvatore has written a great blog very recently on what are the 10 other use cases that you could solve with Redis Streams. So I don't think it's an either-or question. Redis Streams will be used for a variety of use cases, but for the Kafka use case, which is the streaming use case, I think an adapter makes sense. I think people would, because otherwise it's either that or you don't use it right now, is my thought. Right? But Streams is great as a general data structure that you can use it for a variety of other things other than streaming applications.
A question over here.
Okay.
Yeah, hi. Does this work with Spring Kafka?
I'm not familiar with Spring Kafka and the abstraction it provides, but it is if I know Spring in general quite well, and Spring lets you inject an implementation fairly easily. So it should work. I have not tested it, though.
Any other questions? Okay. Thank you, everybody.
Thanks, guys.